So Aaron, do you know much about how exoplanets are actually detected?
I'm a little fuzzy on the details. Would you care to explain?
Alright, so exoplanets are mainly detected by what is known as the transit method. This method involves watching a planet move across a star.
Wait, so the Kepler telescope is actually watching planets go by?
Not exactly. The transit method doesn't actually involve visibly seeing the planets go past, but instead the Kepler telescope uses photometry.
Photometry? What's that?
Photometry is an optical method for measuring the intensity of light coming from various astronomical objects.
So how does that help us find exoplanets?
As the Kepler telescope surveys the skies, it keeps track of intensities of light coming from all kinds of different stars within its wide field of view. As you would expect, when an object passes in front of the light source, some of the light is blocked and some of its intensity is lost.
So you're saying the Kepler telescope can detect when something is blocking some of the light from a star?
Exactly. The Kepler telescope is sensitive enough to detect a dip in intensity when a planet travels in front of a star.
So what happens if you don't see a dip in intensity for a given star?
If a star doesn't change in intensity across the surveying period, one of two scenarios could explain why. 1. The inclination of the planet's orbit is large enough to not transit across our view of the star, and 2. The planet did not transit during the surveying period.
Oh, I see. Then you could also figure out the mass of the star using Kepler's third law of planetary motion. The size of the planet can be found from how much brightness of the star drops during the transit and the size of the star. And from the orbital distance and the temperature of the star, the planet's characteristic temperature can be calculated. And from all this data, we can decide if a planet is habitable or not. So it's possible that some stars have exoplanets, but we just don't see them go past when we are looking?
Exactly. Currently, the Kepler telescope does its best to counteract this by surveying a section of the sky for about 85 days at a time. However, the transiting of an exoplanet only lasts a fraction of a day, so the window of opportunity is very small for detecting exoplanets.